Welcome to my channel, dear students, and all the viewers. And see, today this is the discussion about the application of derivative. Okay, and this is the subject of the rate measure, calculation of the rate measure with the help of derivative. Actually, this is the significance of derivative as the rate measure, rate of changes, and find the approximate value of fourth root of 627 approximate value, and find the approximate value of sine 62 degrees. You know the value of 60 degree, but how can we solve the value of sine 62 degree? And also the logarithm of 10 to the base e. It is logarithm of 10 to the base e is 2.303, and what is the value of that? And also some problem I want to solve this video. Okay, see, first I want to derive the finding the approximation value with the help of limit, actually, which is called the first principle of derivative. From that we are going to derive the approximation formula. Actually, see, you know the first formula, differentiation. This is the first formula, first order derivative formula. This is x tends to 0, x dash, this is x tends to 0 actually, and this is f of x plus h minus f of x by h actually. Okay. Now for calculation of approximation, we don't use here h tends to 0. Just we want to use here like and del. Actually, h is equal to, this is here del x. So we want to apply like that del x and f dash x, and that is equal to f of x plus h, and this is not equal to nearest value. Actually, this is called approximation, and this is f of x plus, and this is del x, x plus and del x, and that is actually f of x plus and del x and f dash x. So this is the formula which I want to use here to finding the value of approximation, that is 1, 2, 3. Okay. So number 1, determine the value of this is question here 6 to 7. So that's why we have a function. Assume the function, this is the fourth root of x here. Okay, now nearest value to 6 to 7, and that is 6 to 5, which is can be findable the fourth root of that is 5 actually. So x here is, that's why x here is 6 to 5. That's why fourth root of 6 to 5 is 5 here. So, and remaining, that is the 2, is called del x actually. Okay. So if we these two added, then we got here 6 to 7. If here is given that the value fourth root of 6 to 4, then we take here 625, but here is 1 is less, so then we can take here del x as a minus 1. Again I repeat, given that the fourth root of 6 to 7, so nearest value, which is fourth root, can be calculated by the fourth root value is easily, that is 6 to 5. So here is a 6 to 7, so del x would be a 2. But fourth root of 6 to 4, then we take here x is 6 to 5, then del x would be here minus 1. Okay. So for this problem, see here, if we differentiate, that is actually x to the power 1 by 4 here. Okay. So 1 by 4 and x to the power 1 by 4 minus 1, and this is 1 by 4, and this is x to the power 3 by 4. Okay. So now f of x means this is 6 to 5. This is here 6 to 5, and del x means this is here 2. So f of This is here 6 to 5. This is del x is here 2, and f dash x, this is the f dash x. So this is here f dash 6 to 5, implies that this is f of 6 to 7, and this is your queries, and this is equivalent to 6 to 5. And this is the function f of x is equal to 4th root of x. So this is the 4th root of 6 to 5, and this is here into 2, and derivative of 6 to 5. Derivative of f dash x, then put the value as 6 to 5. This is here 4, this is the derivative 6 to 5. Then we got here 1 by 4 into 6 to 5 whole to the power 3 by 4. So 4 into 6 to 5 whole to the power 3 by 4 here, and this is equal to, actually this is here 5, this is 2 here. So this is actually 5 to the power 4, and this is 3 by 4. So this is 4 are cancelled. So this is 5 plus 1 by 2 into 5 cube. This is 1 to 5. So the technique of approximation, this is here 5. Now one want to get here as a 10. This is multiplied by 2. Then we got 10. Again we multiply by 2, like that. Actually this is 2 into 5 into 5 into 5 into 5. So this is 10. For remaining to 5, for we multiply here 4, and then we got here 4. So 5 plus 4 by 10, 10 and 10. This is 1000. So this is 5.5 plus 0.004. This is 5.004 is the approximation value of the 4th root of 627. Okay. And now the another problem is there. See, for question number 2. So we have to find the value of sin 62. So that's why we take a function f of x is equal to sin x. Again I repeat, x is equal to 60 degree, which is known value. So in the previous problem for 4th root of 625, this is the known value, that would be 5. And the added value, if we added 2 to the 60, then we got 62. So that's called the del x. This is 2 degree. Okay, but in the formation like f of 60 plus 2 degree, then 62. This is f of 60. This is 2 degree, and this is f dash 60 degree. Okay. Now 2 degree, and this is 2 degree into radian value is given that that is 0.017, 0.034. Okay, this is the radian value. See, in this case, this is f of 60. This is sin 60. This is sin 60 degree. This is actually the value of sin 60 is root 3 by 2, and root 3 by 2 call is the radian value. But here is degree, so radian and degree not to be added to each other, so it needed to finding the value that is radian. This is okay, we want to put the value in place of 2 degree is this. Okay, so this is 0.034, and also f dash, this is f of x is sin x, so derivative is here cos x, so f dash 60, and this is cos 60, so this is here half. Okay, this is here root 3 by 2 plus 0.034 into 2, and that is root 3, that is 1.732 by 2, and this is divided by 2, So we got here 0.017. If we divide this, then we get 8, 6, okay, 6 to the 12, 6 to the 12, 13, okay, carry 1, 8 to the 16, 17, okay, 0.017, 1, 2, 3, 1, 2, 3, 7 plus 6 is 13, 7, 8, and 8.0, and this is the approximation value of Sin62. So check the answer here. Yes, right. 0.0883 is your answer. Okay. Now for third, I want to calculate the question number 3. So problem is here, logarithm to the base e here, the figure is here 10.01. So that's why f of x is equal to, let us assume log x base e. If we differentiate, so f dash x is equal to actually 1 by x. So f of, actually then x is equal to 10. So del x is equal to 0.01. 0.01. Okay. Why we take as x is equal to 10? See, given that x is equal to 10 base e. Okay, this value is given here. So let us assume 10 as a x. Okay. So x plus and del x, and that is equal to f of x plus del x and f dash x. F of 10 plus 0.01. This is f of 10, and del x, this is 0.01 into f dash x, and this is f dash 10, and implies that f of 10.01, and that is equal to, this is f of 10. What is the value of f of 10? If we put here 10, then log 10 to the base e. So this is log 10 to the base e plus, this is here 0.01, and f dash 10, and this is here f dash 10, this is here 1 by 10. So for that, log 10 to the base e here 2.303, and divided by 10, this is here point, so 0.001 actually, and this is actually, okay, this is 2.304. okay, now check the answer here. 2.304, yes, 2.304 your answer. Okay, I think all of you have better understood. Very interesting question, and this is followed by 1, 2, 3. Now we are going to the next problem. Okay, see, I read the question here. The period of oscillation T of a simple pendulum of length L is connected by the relation, that is T is equal to 2 pi root over L by G. Okay, where G is a constant. Find approximately the percentage error in the computed value of T corresponding to an error of 1% in the value of L, and this is the error L, dl by L into 100%, and that is equal to, we got here 1%. It is given that the 1%. For we calculating the percentage error, so we always take a logarithm. Then we get easily, if we differentiate log t without any respect, that is 1 by t dt. So needed to dl by l. Okay, so that's why we take a logarithm. So that is log t to the base e is equal to log 2 pi. Okay, log 2 pi plus half log 2 pi under root l by g, log 2 pi plus log l by g whole to the power half. This is log 2 pi. Properties of logarithm. This is 1 by half log g minus log l minus log g. Here t and l are variable. This is g and 2 pi are here constant. Okay. So differentiate. So that is 1 by t and this is dt. This is here 0 after differentiate. So this is 1 by 2. If we derivative log L, that is 1 by L, and this is dl. And derivative of log g, g is constant, so differentiation is here 0. So now we want to get a percentage error, so we multiply by 100%. Then we get the percentage. So this is 1 by L into dl into 100. Okay, if we calculate the percentage error. So this is your queries, and that is equal to half into, given that 1%. So this is 0.5% is your answer. Okay, this is your queries. Find the calculate percentage error of t. Okay, that is 0.5%. Okay, I think all are better understood. Now we are going to the next question. See. So next question is that, I read the question here. If in the triangle ABC, the side small c and the angle capital C remain unchanged, it means these two are constant, while the other side of the angles are changed slightly. So angle C, angle A, side A, angle B, side B are variable. Then so that dA by cos A plus dB by cos B is equal to 0. So you have to show. So this is here dA by cos A and dB by cos B actually 0. So remains same, small c and capital C. You know from the properties of triangle, as ABC be the angle of a triangle. This is ABC. Okay, this is del ABC, means this is A, B, C. This is small a, this is small b, and this is small c. So actually this C and this is capital C actually remain constant. So A by sin A, B by sin B, C by sin C. So this is constant. Let us assume as a k. Say, so A is equal to k into sin A. Actually small a and capital A both are changeable. That is a given case. Differentiate without any respect. This is dA and this is cos A and dA. Same as C, this is dA by cos A. So that's why divided by cos on both sides. Then you got here k times of dA. Similarly, B is equal to k into sin B. If you differentiate, then dB is equal to k into cos B and dB. From that, and that is divided by cos B, dB by cos capital B is equal to k times of d of capital B, and this is 1 and this is 2. Adding 1 and 2, then we get the your queries, that is dA by cos A and dB by cos B, and that is added this, so to common k, that is dA and dB. So this is k, and derivative of A plus B, you know, the sum of the three angle, and that is pi. So this is equal to k times of derivative of A plus B. This is pi minus c. So differentiation of pi is 0 and c is also 0. Okay, so we got here 0. So given that small c and capital C are constant, this is given, this is constant, so derivative of this c is 0 actually. So this is 0, it's proved. Okay, I think already better understood. Very interesting question for the properties of triangle, and this is how can change the side like AB and AC, CB, and C and small c and capital C are here constant, so that's why let us assume k. And now this is equal to k, so A equal to k times of sin A, differentiate without any respect, that is dA. This is small a, and k times of cos A into dA, and divided by cos A, then we got the k times of dA, and same as b by sin B is equal to k, then b equal to k times of sin B, and differentiate, that is dV is equal to k into cos B and dB, and differentiation by divided by cos B, that is dB by cos B is equal to k times of dB, and adding 1 and 2, then we got this, okay, k times of within the bracket dA plus dB, and this is within the bracket A plus B. No, A plus B is equal to pi minus c. C, pi is constant and c also constant. It is given that the small c and capital C are the constant, not change, and the sides are the A, small a and small b, and capital B are changed here. Okay, so that's why A, B are variable, but small c and capital C are constant, which is given that. So in that respect, this value is 0. It's proved. Okay, now we want to go now next problem is here. See, same problem. I read the question here. Next problem. In the triangle ABC, capital ABC, this is triangle ABC, okay, the sides A and B remain constant. So small a comma b are, okay, constant, but the base capital A and capital B vary, but capital A, capital B vary. Okay, then so that this is dA by under root, that is A square minus B square and sin square A. Okay, and that is dB under root, that is B square minus A square sin square B. Okay, now see, from the properties of triangle we want to write here A by sin A, B by sin B, and that is equal to, and not related to another cases here. So A, B are constant, B are B, A or B are vary. So we take A by B, A by sin A, B by sin B, multiply by these two, A into sin B and B into sin A. So now differentiate, A and B are constant. So this is cos B and dB, B are constant, so that is cos A and dA. See, this is dA. So now write here dA divided this and divided by this. A cos B is equal to dB by B cos A. So implies that dA within the root here, A square cos square B dB under root B square cos square A, implies that dA by under root, we can write here sin cos square B, that is 1 minus sin square B. So multiply by A square. So A square minus A square and sin square B, same as dB by root over, this is 1 minus sin square, so B square minus B square as sin square A. Okay, now from that dA by under root a square. So a sine b, in case of a sine b, so this is a sine b, we can write here b sine a, and this is db. C, so this is here b square. In case of b sine a, we put here a sine b. Okay, and this is proved. dA under root of, this is a square minus b square and sine square a, that is db by under root b square minus, and this is a square sine square b, proved. Okay, if you enjoy this video, then share this video to all of your friends, and also don't forget to subscribe my channel. Thank you.